Okay, so today's we have 20 questions from alcohol, phenol, and ethers. Baki chapter we I think yes, like hydrocarbon. Even some questions are from aldehyde, ketones, carboxylic acid. Means it is overall we can say revision of whole organic chemistry. Okay, so first question is, what are X and Z in the following sequence of reactions? So first, say when we have HgSO4 in the presence of dilute H2SO4, so always keep in mind that this HgSO4 means it is, sometime it is written like this, Hg2 plus H plus. So it means there is a triple bond which is undergoing hydration.
Okay, so Hg2 plus forms a non-flexible carbohydrate, right?
Yes. So actually what happened, this Hg2 plus hold one pi electron of triple bond.
Yes.
Because you know this pi, the two pi bonds, they form cylindrical shape.
Yes.
Like this, means there is a delocalized pi electron cloud. That's why alkyne is less reactive than alkene towards addition reaction. So in case of alkene we use only H plus, H2O in H plus, but in case of alkyne we need to use one more reagent, means HgSO4 along with water and H2SO4. So ये एक इंडिकेशन है that you have one triple bond in the compound. So anyhow, X is alkyne, that is clear from the statement that HgSO4 and dilute H2SO4 is used. Now next is when this Y is formed, that will react with some Z in the presence of dilute NaOH. Yes, whenever we have a dilute NaOH, in most of the cases, you know, we have, and there is indication is there is a keto group in the compound. So we can do retrosynthesis here. We start from product. So let us start from the product. You know, the product we have is pH double bond. This is the product. Now if it undergoes, it is formed by dilute NaOH, means aldol condensation is carried out. That means the products of reactants of this particular reaction is, because you know this is CH double bond O, and on the other side there is CH3C double bond O. So it is obviously CH3 because two alpha hydrogens are removed from this.
Okay, sir.
And from here only double bond O moves away. Okay, so in this way we get these two products.
All right.
Now you can go for options. So say this is either benzaldehyde or acetaldehyde. So we can say that attack is taking place on the benzaldehyde.
Yes.
That means one of the reagent is benzaldehyde and other is either acetone means it should be, Y should be acetone if we take Z as benzaldehyde. So Y should be acetone. So from this point, X should be an alkyne with 3 carbonates.
That's a propane.
It should not be but2-ine because that will form 4 means ketone is formed but with 4 carbon atoms. So it should be
Yes.
propyne, because in propyne, when hydration takes place in the presence of HgSO4 and dilute H2SO4,
This follows marketing of this, right?
yes, first of all, OH is added here.
Yes.
We get enol.
Yes, sir. And tautomer exists.
Yes, there is a tautomerization, and due to tautomerization, there is shifting of hydrogen. So we get acetone. So in this way, what will be the product? It should be option A. So these are the X and Z in the reaction mixture.
All right. Subdivision here, there are IAT questions.
Okay, IIT main or advanced?
IAT, sir.
IAT, okay. Means ICER exam, right?
Yes.
Okay. Next question is, which one amongst the following is the most efficient way of synthesizing normal propyl benzene? So see, to get normal propyl benzene, you know, if we have first one, first is
Fiedel-Crafts acylation.
yes, first is Fiedel-Crafts acylation. So when benzene is treated with this propanol chloride, you know, Cl is removed
Yes.
and it becomes CO, CH2, CH3, right?
Yes, sir.
Because this whole part attached to Cl, to benzene, because it is Fiedel-Crafts acylation.
Yes.
Now, what is, yes, it is Wolff-Kishner reduction because we have KOH and hydrazine. So in Wolff-Kishner reduction, what happened? CO group is converted into CH2. So we get normal propyl benzene. That means this is the right option. Let us go to the second one. So in second one, we have benzene. So at the same time, we have CH3, CH2, CH2Cl in the presence of anhydrous AlCl3. So when anhydrous AlCl3 is used, Cl is removed and we get this carbocation. So this is primary carbocation.
Yes.
But whenever carbocation is formed, you know, first of all, most stable carbocation is formed. So there is a 1,2 hydride shift, and 1,2 hydride shift leads to the formation of isopropyl carbocation. So that's why when this reaction takes place in the presence of anhydrous AlCl3, we ultimately get this as the major product, that is isopropyl benzene. और क्या बोलते हैं इसको?
This is
Common name, very important common name, cumene. So it is also called cumene. In the next case, you can see we have again CH3, CH2, CH2OH. Yes, in the presence of H plus, first we get protonated alcohol, then this, it is removed, we get primary carbocation, and then it is rearranged to secondary. In this case, in the presence of H plus, we get this carbocation, because H plus is added first in the alkene. So more stable carbocation is formed, means in all the three cases we get isopropyl benzene as the major product.
yes.
Right?
Understood.
Okay, that means first is the right option. Correct. Okay. Now this question, first of all we have phenol. Phenol can react with sodium hydroxide, and this accounts for acidic nature of phenol. So we get sodium phenoxide, and then with methyl iodide, this is Williamson's ether synthesis.
Yes.
So we get anisole, methoxybenzene. Now, when methoxybenzene is treated with, again, Friedel-Crafts acylation,
Yes. We will get para isomer.
the major isomer is para. We get both the isomers, but major one is para, because OCH3 has which effect? Plus R, due to the presence of lone pair. Whenever atom directly attached to the ring has lone pair, then it has plus R effect. Means it is electron releasing, it is activating group, and therefore increase the electron density at ortho and para. Okay, so it is ortho para directing, so we get both the products, ortho as well as para. So we have both the products.
Like I said, जब तक कुछ mention नहीं किया, we will assume a para to be the same.
Yes, major is para. Then next is we treat it with NaOCl. If we treat it with NaOCl, what is this? This is NaOH plus Cl2.
Yes, sir.
It is chloroform reaction. This is chloroform reaction, and we get C double bond O Na along with CHCl3. From this we get OMa, CO, ONA and CHCl3. So see, in the first case it is like this only.
Yes, sir.
In the second case it is different. In the first point is different. Here first is okay, second is okay, but third is different. In this case, first is okay, second may be okay because it is formed, but third is not possible because it hydrolyze the ether as well, means it break the hydrogen. That is not possible, right? So that's why first is the right option. Okay, I think most of the reactions are covered. So what is the name of this first reaction? Yes, H2PD in the presence of barium sulfate. This is, yes. So in Rosenmund reaction, we get aldehyde. Then when it is treated with methyl magnesium bromide, we get OMgBr and OM and CH3. Then on hydrolysis, we get this product, Mg positive, O negative, because when pi electron shift here, methyl is negative and MgBr positive. So in this way, we get alcohol, and this alcohol, when it is treated with CrO3, this one is P, this is Q, and on treatment with CrO3, we get this product, this is R, and now zinc amalgam and HCl.
This is Clemenson.
Clemenson reduction. So CO is, O is changed to H2.
Yes.
This is Clemenson reduction. So in this way, we get S. So options are products P and R can form addition product with HCN. So HCN has characteristic test with aldehyde and ketones. So P is aldehyde and R is ketone. Both can react with HCl. That means first option is correct. Product Q has no chiral center. So see, in product Q, this is chiral center. So that means second is incorrect. Third, product R can undergo K0. Product R, no, because it has alpha hydrogen. It has alpha hydrogen, so it cannot undergo K0 reaction. That means third is incorrect. Aldehydes or ketones having no alpha hydrogen. Sorry, aldehydes having no alpha hydrogen. Okay, so R is already a ketone, therefore it cannot undergo K0 reaction. Okay, now product S is a saturated hydrocarbon, right? Identify the correct statements. It should be first and fourth both.
This is IAT question, but this is the option
Okay, anyhow. So first and fourth is right statements. Okay. Next is the major product of the reaction of salicylaldehyde. What is salicylaldehyde? With one equivalent of methyl magnesium bromide. Methyl magnesium bromide. So, first of all, why it is safely written as one equivalent? Because if it is more than one, it can react with alcohol, phenol as well. But, aldehyde is more reactive than phenol towards Grignard reagent. So there is an addition reaction. CO, there is a shifting of pi electron, methyl negative, Mg positive. So carbon positive, that will be attached to CH3. So it is CH3 and O negative, MgBr positive. So in this way, and on hydrolysis followed by acid neutralization, so we get OH and CHOH, means it can be written like this. No. It should be like this only. Okay. Oh, yes. Because it is simple alcohol. How do it automerize? Because it is not enol. So this is the product formed, right? This is simple alcohol, this is phenol part. So that means first is correct. So B option is correct. Next, what is the final major product of the following reactions? So पहले तो keep in mind that KOH can give you the first bromine can be removed by KOH in alcoholic KOH. It is simple beta elimination reaction. But if it is vinyl halide, vinyl halide, this is vinyl halide, right? And vinyl halide has double bond character. And because of double bond character, it is very difficult to remove X from vinyl, halide halogen from vinyl. But if we use strong base like NaNH2, we can remove it. But alcoholic KOH cannot remove. So that means both Br are removed one by one along with H. So first beta elimination will give double bond, and second beta elimination that lead to the formation of a triple bond. It is a base, strong base. It will abstract hydrogen. So in this way we get this product. first HBr and then second HBr. Okay, so we have benzamide on treatment with bromine in ethanolic NaOH. What is this? This is Hofmann bromide degradation. So when Hofmann bromide degradation takes place, you know, CO is removed by NH2. So we get aniline. So after getting aniline, we have to treat it with bromine water. So bromine water will, you know, NH2 is orthopara directing. So in this way, what will we get? Yes, orthopara 2,4,6 tribromo aniline. That is the product. Next, we have propene. First, when it is treated with HBr, it is by Markov-Nikov rule. Second, in the presence of peroxide, so it is anti-Markov-Nikov rule. So first we get 2-bromo propane. In the second case, we get. So which of the following is the correct pair of intermediates responsible for the formation of X and Y as the major products in their respective reaction? Okay, we need to know the intermediates. That means we will go to the mechanism side, right?
Yes.
So you know that in first case there is addition of HBr. H is positive, Br is negative. And what is the type of reaction? Yes, it is electrophilic addition reaction. So first of all, H positive will attack. It is added up and we get this carbocation, secondary carbocation, and this is the rate determining step, slow step. In the second case, you know, first of all we have benzoyl peroxide. So there is homolysis. We get benzoyl free radical. Then ultimately we get phenyl free radical. And this phenyl free radical react with HBr. And we get benzene along with bromine free radical. Now, in first case, see, H positive is added. But in this case, first Br free radical is added. It leads to the homolysis. And we get again secondary free radical, because secondary free radical is more stable than primary. So this is formed in the major amount. Here it is formed in the major amount. So in both the cases we get secondary products, means intermediates, secondary carbocation in first case and secondary radical in the second case. So it should be option C. Sorry. Okay, sorry. secondary carbocation, secondary radical. Next, in the following reaction sequence, identify the relationship between products Q and S. So now see, in case of Q, we have treatment with CH3MgBr in both the cases. So first one is CH3 CH2 C double bond O H, CH3 negative MgBr positive. So this will attack leads to the formation of CH3 CH2 O MgBr and CH3. Now when it is treated with H2SO4, we get CH3 CH2 CH OH CH3, right? Now in the second case, again there is CH3 negative MgBr positive. This negative part will attack here. So we get CH3COMg, yes, Br CH3 CH3, and then on treatment with H2SO4, we get tertiary butyl. So first one is secondary butyl alcohol, other one is tertiary butyl alcohol. And it is tertiary butyl alcohol. So they are isomers. Okay, heat. Okay, it is not H2SO4 dilute, but it is okay. There is heating as well, right? H2SO4 heating. Okay, this is P and this is P. This one is P and this is R. Okay, on heating, you know, you apply Set-Jef rule in this case. So first case mein we get but2ene because poor becomes poorer. In the second case we get isobutylene. So they are again isomers. Which type of isomers? Structural. So they are structural isomers. Both are structural isomer, right? Next, arrange the following compounds in increasing order of their rate of reaction towards hydroxyl ion. So you know hydroxyl is behaving as a nucleophile here. So you know when nucleophile attack, it will attack on the ring where electron density is low. So we need electron density should be low. So you know these withdrawing groups will decrease the electron density. So that means first has 3 withdrawing groups. So it is most reactive. So first is most reactive in, okay, A, C, D. So we reject this. Yes, in first case it is minus I minus R. In here it is minus I only. It is again minus I minus R. So third should be least. So third is least in C only. So we can get an idea. Now if we compare ortho and para, you know in ortho case, yes, minus R is same in both cases, but at ortho position minus I is more, so it is treated as more withdrawing, right? Okay. In which one of the following cases will the alpha hydrogen not be abstracted on treatment with one equivalent of base? Yes. There are alpha hydrogens, alpha hydrogens, alpha hydrogens. So tell me which alpha hydrogen is not abstracted when only one equivalent of base react.
Option D, sir.
Option D? No, it should be option B. Why is it so? Because you know when one equivalent of base is there,
Okay, it's carboxylic acid.
so first of all it will be carboxylic hydrogen that will react. Okay. So in this way, B is the right option. In rest of the cases, you know, it can, because it is the only one which can react. Because in other cases, only alpha hydrogen is acidic. But here there are two options and this one is obviously more acidic. So it will react first with the base. Okay. In the following reaction sequence, predict the structure of the final product Y. So first we have ethylene glycol in HCl gas. So it leads to the formation of it should be like this, right? Beta, it is acetal formation or ketal formation, sorry. protection of keto group. Right? You know, this is the reaction. C double bond O, CH2, CH2, OH in dry HCl. We get this ketal formation. This is used to protect this group. Now with lithium aluminum hydride, you know, hydride group is added, and in the H
reduce the
ester into alcohol. Okay. Yes. You know, lithium aluminum hydride is strong reducing agent. It can reduce. Okay. There is one reaction for ester when because lithium aluminum hydride is an expensive reagent. So on ester formation, we can treat it with H2PD. That will serve the purpose. But here we will use lithium aluminum hydride we are using. So we can do the same. Yes. Oh, no. Is the ester okay? In the along with in this case, what happened? H negative ion will attack here. Okay. And H positive from water will attack here. So it becomes OH. Wait, I will draw picture. See, we have this C6H5. So lithium aluminum hydride will give H negative, and that H negative ion attack here.
and H plus from water will attack oxygen.
In this case, it is like this H2 that will H 4 times. Al like this. Okay. So Al and OCH3 is removed completely, and C6H5. So it should be, because this is replaced by H negative only, so it should be like B, option B. And if water is used, because some acid is required to hydrolyze this, then we get this product. Okay, means lithium aluminum hydride reduce the carboxylic acid, ester, nitrile, aldehyde ketone into alcohol.
So alkane तक भी लेना सकते हैं.
अल्केन, फिर नेक्स्ट स्टेप में आपको अल्केन तक कैसे ले जाएंगे? नहीं, अल्कोहल से अल्केन तो बना सकते हैं, बट नॉट बाय दिस reagent. Next is, for the following reaction, identify the carbonyl compound X that shows the highest reactivity. So, this one, yes, but this is acting as nucleophile. So, this nucleophile will attack on this carbonyl carbon.
Yes.
So, this carbonyl carbon, this is ketone. So, it is straight rejected because we need one which has highest reactivity. Aldehydes are more reactive than ketones towards nucleophilic addition reaction. And second is, if withdrawing group is attached, that will enhance the reactivity, because that will increase the electrophilic nature of carbonyl carbon. Right? So now that's why this B and C are more reactive than A, because in A there is a releasing group. So out of B and C, NO2 has minus I as well as minus R. CN has again minus I minus R. Here nitrogen oxygen, so they have strong minus I as well as strong minus R, NO2. But CN has minus I and weak minus R. That's why NO2 is more electron withdrawing than CN.
Yes.
So B is the right option. Next, identify the major product in the following reaction. We have ketone. Now this ketone, when it is treated with CH3CH2 MgBr, this is OMgBr, CH2CH3, C6H5.
Yes.
Now H2SO4 concentrated, reflux. What happened?
Let's say
Yes, dehydration takes place. First it is OH, then I think this should be the product. Right?
Won't it have more alpha hydrogen if it forms on the other side?
But here what happens, see, there is more delocalization. Got it? Conjugated system is formed. So that is more probable. So now when ozonolysis takes place, a reductive ozonolysis, so you know this double bond breaks. So we get CH3, CH2, C double bond O.
Yes.
Then 1, 2, 3, 4. 1, 2, 3, 4. And then again C double bond O and C6H5. That means this is the product formed. So C is the right option.
Okay.
Got it? Okay. Okay.
These are now AVP questions after this.
Okay. In the reaction glucose in the presence of yeast, we get X, and then X is treated with KMNO4. So obviously we get ethanol, and on treatment with KMNO4, you know, it is a strong oxidizing agent. So we get acetic acid. That means A option is correct. Esterification of a compound X with molecular formula C3 C3H6O2 with an alcohol. That means it is carboxylic acid.
Yes.
So there is this is the carboxylic acid. And it is treated with alcohol. So this should be X. And there are 5 carbons. So alcohol should be of 2 carbons.
Yes.
And we get CH3, CH2, C double bond O, O, CH2, CH3.
Yes, sir.
So we get propanoic, we have X is propanoic acid
Yes.
and Y is ethanol. That means B option is correct. Ethanol on reaction with alkaline KMNO4 gives X. So what is X? Yes. Ethanol on treatment with KMNO4. So we get acetic acid If there is alcohol, then there is no difference. That will give potassium salt. Right? They are strong oxidizing agent. When it is treated with methanol, what will we get?
We will get an acid.
Methyl acetate.
Yes.
So that means option B. Acetic acid, this is X, and Y is methyl acetate. Oh, alcoholic KOH and NaOH. I hope this is Br, na? It should be Br. Reason being, there is alcoholic KOH and NaNH2 both. Okay, so it should be pH, C triple bond CCH, because double dehydrohalogenation takes place. Now HgSO4 H2SO4. It is like this, and then it is enol, so that will give keto form, and keto should be more stable than enol. So benzaldehyde, and then on nitration. This is benzaldehyde. This give meta nitrobenzaldehyde. Okay. So it should be first one only. Okay. In the following reaction, we have propyne with Hg2 plus and H3O plus. So obviously, again, there is enol. Hg2 plus H3O plus means HgSO4 H2SO4. Right? So we get acetone, and acetone with dilute NaOH and benzaldehyde. What is the reaction? Yes, it is aldol condensation. Because there is cross aldol condensation. So we get this product. So in short, we get pH, CH double bond CH, C double bond O CH3. That means B is the right of. Right? Reaction of ethanol with concentrated first of all we get ethene
Yes.
because it is 343 Kelvin only, which is then treated with so we get vicinal dibromide.
Yes.
This is the test for unsaturation as well, because this is reddish orange in color and it become colorless. So it is 1,2-dibromoethane. So it is 1,2-dibromoethane, means A option is correct. So that's all. Okay, so you will collect questions. Okay, in the target of 20 questions at least in one session, and that will revise your organic chemistry, I think, in a better way. What do you think?
Yes, sir.
Yes, yes, why not? That, I think that's better because all the concepts you know. So if you brush up the concept by question answer, that make a grip on the topic, means concept, right? Okay then, bye bye beta. As soon as you send me questions, I will arrange. As you wish. Okay. Yes, I will send. Okay. Bye bye.